So I'm going to try to solve a problem where you are asked to find if x of n is equal to cosine pi over 8 times n squared is periodic or not, and if it is periodic, what is its time period. So the way I think about solving these problems is to say, okay, if this signal is periodic, then what should happen is this: we should be able to find a number capital N which is an integer which is greater than 0 such that x of n plus n is equal to x of n for all time little n. That's the definition of a signal being periodic, right? So what we'll try to do is to see whether we can find such a value of capital N. And if we find such a value of capital N, then we know that the signal is periodic. Then we'll try to find the smallest such value which is greater than 0, that will give us the time period. What is x of n plus n? If you go into this expression here, you realize that this is cosine pi over 8 times n plus n whole squared. And this should be equal to cosine pi over 8 times n squared, and you want this to be true for all values of lowercase n, right? Okay, now one thing you realize is this: if I have a cosine of something here, you have cosine of something on the right hand side. If cosine A is equal to cosine B, what can we really say about A and B? Can we say that this has to be equal to this? I mean, if this is equal to this, it would certainly be true that cosine of this would be the same as this. But it's also possible for this to be 2 pi more than this, and the cosines would still be the same, right? It could be 4 pi more than this, the cosines would still be the same. So in general, as long as one of these is an integer multiple of 2 pi more than the other, the cosines would be the same. So what that really means is the difference between these two have to be an integer multiple of 2 pi for this statement to be true. So what that means is pi over 8 times n plus capital N squared minus n squared should be an integer multiple of 2 pi. So k is an integer. Can be any integer, right? So now we can cancel the pi on both sides, and we could move things around a little bit. I could multiply by 8 on both sides, and then you would end up with something like this. Okay. Now what we are asking is this: can we find a value of this capital N such that for all integer values of this lowercase n, this is an integer multiple of 16? Mm-hmm. It doesn't really matter what multiple of 16 it is, it just has to be an integer multiple of 16, right? So let's just do some manipulation of this. You can use the identity a squared minus b squared is a plus b times a minus b. And then the left hand side you can write it as 2n plus n times the difference between 2, which would be capital N, and we want this to be equal to 16 times k. So if I expand this out, I get 2 times n times capital N plus n squared. I want this to be equal to 16 times k. Okay, so now what you can do is you can plug in some numbers of capital N and see whether this is going to be true for this, just to get a feel for what's happening here. So if I plug in n is equal to 4, for example, capital N is equal to 4, is this always going to be true? Well, it's not always going to be true. If I set my small n to be 1, for example, 4 squared is 16, 4 times 2 is 8, 8 times 1 is 8, So 8 plus 16 is 24, which is not an integer multiple of 16, right? So 4 doesn't work. So if you think about this a little bit, you will see that 8 works. Because 8 squared is going to be 64, which is always a multiple of 16. 8 times 2 is 16. So 16 times any integer is going to give you an integer multiple of 16. So the left hand side is clearly a multiple of 16, integer multiple of 16 when capital N is 8. And in fact, that's the smallest value of n for which this will be true. So indeed the signal is periodic and the time period is 8.